Okay, so next speaker is Professor Zhang Yahua from the University of South Australia. His speech topic is air transport, decarbonization, pathway, challenges and opportunities. 20 minutes for speaking and 10 minutes for answering questions. Okay, please, Professor Zhang.
Okay, thank you. Thank you for the introduction. I'll just bear with me. I'll share the slides. Okay. Yeah, a little bit changing the title here. Okay. Thank you for the organizer, and it's a pleasure to share some ideas on sustainable aviation fuel, which is quite important to the aviation sector and to achieve the net zero by 2050. I need to acknowledge the founding organization, which we have received a research grant from the National Foundation for Australian-China Relations to support this project. So first, what is sustainable aviation fuel, or SAF? Sustainable aviation fuel are defined as renewable or waste-derived aviation fuels that meets sustainability criteria. And we should mention shortly that it should not compete for land or water with other crops and food. And normally SAF is alternative liquid fuel that made from agricultural waste, forestry residues, and urban waste and hydrogen. And it's equivalent to conventional jet fuel. Currently, the maximum blended ratio is 50%. From next year, there's a mandate in the EU that all airline departures need to have a blend of minimum 2% of SAF. And then in the next 5-10 years, this percentage will increase to 5%, 10%, and by 2035, should be around 15%. And I expect the other countries will follow suit to set such mandate, requiring airlines to increase the percentage of SAF in their jet fuel. So research has shown that there's potential that using SAF can reduce CO2 emissions by up to 80%. So obviously, why do we need SAF? It's because we want to address the climate change problem, and we want to meet the net zero target. So if we don't do anything, you can see, since 1966, the CO2 emissions by aviation has been keeping increasing all the time and continue to grow in the last few years, and will be so in the next few coming decades. So currently, we know the aviation contributes about 3% of the global total emissions. But if we don't take any actions by 2050, its contribution could reach 22%. So just give you some information about the different transport modes in terms of their emission. So you can see aviation contribute about 11 to 12% for for the transportation sector. And the question is, are there alternatives? We will discuss this shortly. And obviously improve the operational efficiency. Yes, it could help reduce emissions a little bit, but not a good solution to the emission problem. And also considering other transport modes like high-speed rail. So that's the case in the EU, where the short-haul flights have been cancelled, and also promoting the use of video conferencing. That's a technology quickly developed during COVID period. But the thing is, it cannot replace face-to-face meeting completely. And we love to meet people, interact with people, and so video conferencing would not reduce business travel. And also using carbon offset. So plant more trees, and so when you travel, airline may ask you to contribute some money so that they can use the money to plant trees or use on other projects to reduce emissions. So that could be possible, part of the solution, but again, not an efficient solution. It only helps reduce your guilty for traveling. So you contribute to the reduction, you contribute to offset, but it does not really solve the problem, because once you have paid, you don't have the guilty, then you could fly more and you contribute more footprint carbon emissions. And also we know there's development in new technologies, electric powered or hydrogen powered aircraft. They are quite feasible, but at this stage, it seems they would not be the final long-term solution to achieve net zero by 2050, because they can only be used in short haul flights or on short distance routes. So the solution the only solution at this moment would be sustainable aviation fuel. And we just mentioned it could reduce up to 80% of emissions. As you can see, improve operational efficiency is probably not possible a solution to achieve net zero, because passenger demand keeps growing, and so does freight demand. And also we just mentioned video conferencing, high-speed rail, not possible in many countries. Only China got a very good network of high-speed rail, but still not available in many other countries. And the carbon offset program, it could make you feel good, but would not resolve the problem. And hydrogen and electric powered aircraft, they are okay for short haul flights, but not for long haul flights. So aviation is well known as one of the few hard to abate industries, and SAF has been emerged as a feasible solution. It's a drop-in fuel that can be blended in any proportion with the traditional jet fuel without doing any change to the existing aircraft design. But the thing is, for SAF, there are significant barriers for large-scale production, and also commercial adoption is still slow in progress. And the kind of research had paid very little attention to the engineering part of SAF, including its economic viability, its impact on airline competition, and also the role of government in stimulating the production and adoption. And also we mentioned the cost of SAF is quite high, probably 3 times higher than traditional jet fuel. Airlines would not have incentive to switch to SAF. And also SAF producers, they would not increase the production unless they see a demand. So that's why we need a government intervention to break the cycle. Okay, this research I want to present is to have a survey of the current literature and see what have been done in current studies and what have not been done. So hopefully it cover some useful, interesting information that you can find. So we use a systematic literature review method following this procedure. And we use the keyword sustainable aviation fuel, the keyword here. Why we use this? Because this is almost a standard term used in the aviation sector in recent years. And we focus on the top ranking journals. So it give us 141 articles. And you can see the keywords, this word cloud. Obviously, the bigger font shows the word all on the production side or supply side. So for carbon emissions reduction for aircraft and environment rather than for end users or airlines. So currently, existing studies mainly focus on supply side of SAF, not on demand side. So you can see most papers published in energy journals. For my areas, for business, well, as a economist, and I would say more papers to be published in business management and transportation journals. And okay, these are the research methods that you mainly used. I'll skip over. And we have identified 5 main themes in the existing literature, SAF and other decarbonization solutions. So they mainly make comparisons between SAF and other solutions. And also pathways and feedstock or technologies. And also economic feasibility, SAF supply chain, job creation, government intervention. So we discuss each of these things one by one. So there should be criteria for good feedstock for producing SAF. So the ideal feedstocks should be abundantly available, not compete with food production, and have low indirect land use charge change. So actually FAA has listed the potential sources like used cooking oil and grease, and also coal huts and greenhouse and wood waste, and also seaweeds, algae, and carbon CO2 from air, which can also be combined with green hydrogen. So that's another source. So currently, I'll show you there are certified pathways here. Only the first one, we call it HEFA. HEFA, in China, there have been many SAF producers using this pathway. They use used cooking oil to produce SAF and export to the EU, where there will be a mandate for using SAF. And the entry barrier is quite low, so we have seen a lot of SAF producers in China using this method. They mainly using they use the cooking oil. So at this stage, I can tell you you would not worry about you when you go to restaurant, you will they will use the cooking oil for your food, for your dishes. know the current used cooking oil price has been very high, and we have a better use at the moment. So that's probably good news for consumer. And HEVA is the only mature technology that allow a large-scale production of cell at the moment. And another technology is HJ. So sugarcane and also agave or some other plants that contain a higher level of sugar that can be used to produce ethanol and then continue to produce to be converted to SAF. So the other pathway is still not quite mature and still in piloting. So more details in here, I'll skip over. So so literature has suggested that HEVA is the only commercial pathway currently used at scale to produce SAF. And the HEVA mainly use lipids, which are found in used cooking oil with grease, animal fat. So a lot of SAF producers, they asking me, they want to have connection with Australian cattle and the sheep industry to import some animal sheep grease, sheep fat, or cattle beef tallow that will allow them to produce SAF. And also there's much effort here to identify new oil sources. Okay, I'll skip over this. And there are alternative decarbonization solutions. So Japanese researchers, they have compared non-SAF strategy to other strategies. So it had been found the long future technology pathway can reduce emissions by 27%, but it comes at a very high cost. So that means domestic flights will be replaced by railway transport in Japan, and the airfares should increase by up to 48%. So that means the alternative solution would not be quite feasible. And also, yeah, we already mentioned the hydrogen electricity powered aircraft are viable for short haul flights. And hydrogen, I believe it could be the ultimate solution for the future. But airlines, we know airline industry is a very unprofitable industry, where all the airlines just make very thin profits, and for most of the years they make losses. So how can they quickly retire the current aircraft fleet and buy the new hydrogen-powered aircraft? So airline may not want to adopt that very quickly. And also one thing is about economic feasibility. So we understand the SAF is not currently economically viable for airline because it's too expensive. And how to reduce the cost is a research topic. And also limited availability of liquid feedstock. So even HEVA is we think we produce a lot of food waste, and that contains a lot of used cooking oil, but still not enough for to meet the demand. So the feedstock problem is not solved. That's why the SAF producers, in China, they eye to Australian cattle industry and say if they can import animal fat and grease. And also we know there's a high cost associated with setting up a biorefinery plants. And also there's a lot of logistic challenges involving production, transportation, storage of SAF. And also there have been ongoing debate on safety concerns for using SAF. So that means most likely airlines will conduct more frequent inspections. So that means higher cost for airlines. And also currently there's no standard reporting requirement for SAF production. And the purchasing price from such information, purchasing price of feedstock is very unclear. So it's hard to evaluate the cost. So all these limit the large scale production and also limit the design of policies for this new industry. And also one thing focused on self-supply chain. So I will probably skip this. And also I just want to mention that SAF will involve farmers, logistic operators, transportation sector, and of course, eventually aviation sector. So it will create a lot of jobs, and it will require significant skills. That means we needed to convey this information to countries that still do not want to produce SAF and use SAF. That SAF could be a good opportunity or new economic engine for their economic development. So this could entice them to act on producing and adopting SAF. And finally, I just want to mention some government intervention. So we need the government to step in to break the deadlock and initiate some actions. So yeah, here's some information that about the EU, which has been taking action imposing quotas by requiring fuel supply to blend 2% SAF by 2025, by 2030, and at least 62 by 2050 at all EU airports. So this mandate is easy to monitor, but we know so economists know that this is not an ideal method. It's not market-based, but it's easy to monitor to achieve the minimum level of reduction. But in future, some other market-based approach should be introduced. And also there should be more research to pay attention on the macro level and address the need for international collaboration to promote SAF production adoption, given that air transport or aviation is a cross-border industry. And also at the macro level, there should be research on passengers' acceptance of SAF and how they can participate or contribute to the adoption of SAF by airlines. Okay, finally, of course, all the emerging STEM have not been fully explored, and more research should be needed. And other research directions include that more studies on exploring new SAF conversion pathways, technology, and feedstocks. So currently, I'm working with a farmer who's growing agave, a plant that contains higher sugar level, even higher than sugar cane. which could be a feasible solution. It will take probably 7 to 8 years to grow before we can harvest the leaves for self-production. And second, given the transboundary nature of international flights, so it's important to promote international collaboration in setting safe adoption policies at a global level. And third, the role of SAF as a new economic growth engine and a source of new jobs needs to be explored, particularly in developing countries. I think many Chinese SAF producers have seized the opportunity. They have Chinese people really smart. They could see the opportunity and they act very quickly than what we more quickly than what we can imagine. And also the general public's understanding and acceptance should be studied. Without their support, airlines may not act as quickly as they should be. And finally, research on the impact of adoption on airline competition on the related industries such as tourism, agriculture, and road transport should also be valuable. Okay, here's that's pretty much I want to talk about. Seth, if you have any question would like to answer?
Yes, there are 2 questions.
Okay.
Would you like to answer in the chat box?
Yeah, redirecting subsidy to current and disposable to SAF. Yes, that's one recommendation. Can they cover the high cost of SAF? No, and this it will provide partial incentive to the SAF producer or airlines for them to switch. Is it possible that the use of SAF will make the burden of government input more heavily? It will make airline the burden of airline. The airline will have a higher financial burden for the switch to SAF, and for Chinese carriers like Air China, they're all state-owned airlines. Probably yes. Government support will be needed, more government support will be needed at some stage. Yeah, it could be a burden for the government. We can find the EU is taking the lead, yes. Judging from the recent development of self-technology, yes, the mandate I just mentioned, it sets a minimum, the floor, minimum limit we can achieve. So that will lead to higher cost and to airlines, and airlines should be able to pass out part of the cost on to consumers. So once other countries follow suit, set mandates, then we will expect the air travel will become more expensive. So higher airfare should be a norm in the future if we have a determination. So it really depends whether the government has the determination to reduce emissions in this sector. Yeah. Any other questions? I can't see any
Do you
other
have any
questions.
questions?
Yes, please.
No, okay. It's time. Just time now. Okay, thank you very much, Professor Zhang, and we'll end this speech. Thank you very much.